In this video, I'm going to talk about using synthetic division to help with factoring. Of course, there are many other things that can be done with synthetic division. We're going to focus on just factoring because it is something that will come up a lot in calculus, and as we get higher degree polynomials, it can be a helpful little trick. So what I'm going to say is pretend that we've already tried grouping, we've already tried everything else, and none of our other tricks work. So what I'm going to do is bring up my calculator. And you can see I already graphed it. I already put it in the y equals line. I already graphed it. And what I'm doing is looking for x-intercepts, right? Because those would be factors. So, and I'm going to look for a number that I want to try dividing by. So to me, it looks like 2 may be a factor. So I'm going to synthetically divide by 2. So I'm going to put a 2 on the outside. So I'm going to put my coefficients down. So -6, -8. I bring down the 1. Just starting with the number on the outside, and we're going to say 2 times 1 makes 2. The numbers on the outside multiply, so when it's the any number that's not inside my little bar here is multiplying. So 2 times 1 makes 2. On the inside we add, so 2 plus 3 makes 5. And I repeat, 2 times 5, right? I'm always multiplying that, and now I'm on the 5. So 2 times 5 makes 10. 10 plus -6 makes 4. 2 times 4 makes 8. 8 plus -8 makes 0. And if you remember the remainder theorem, this says if we were to substitute 2 into this equation, I would get out 0, which is a factor. That's exactly what we're looking for. Or you think of it as like a y value. When I plug in 2, I get out 0. Perfect. So now we just have to remember what this will look like factored. We started off with x cubed, x squared, x, and then this would be x to the 0. It's a linear term, right? So when we factor out x minus 2, and I'll go back and review why that's x minus 2. It came from right here. Okay, then notice the sign changed. Everything went down by a degree, because if we were originally x cubed and we factored out an x, now we'd be down to x squared. And now, so the numbers here on the bottom, the numbers I just highlighted in blue, will be the coefficients of my other factors. So it'll be 1x squared plus 5x plus 4. So you can see the blue coefficients gave me this piece, and the yellow remainder is this piece right here. Now, why is it the opposite? Why is it -2? Well, remember, what we're saying is when I substitute in 2, I better get out 0. And so this factor says when I substitute in 2, I need to have 2 minus 2, right? So if I had, instead of writing -2, if I had written +2, that wouldn't give me a 0. That would give me 2 plus 2, which would make the whole thing 4, and therefore that's why it needs to be negative. Right? So that way, when we substitute in that 2, we actually get out the right thing. And if you were to take this x minus 2 and distribute it through, you absolutely would get back what we started with, which is the whole point of factoring. Now that we've done the synthetic division once, we can factor the remaining part, there we go, the part highlighted in blue, using another technique if needed. So you can see it's a quadratic. So we could just factor saying what times what makes 4 adds together to make 5. Oh, that's not too bad. That would just be a +4 and an x plus 1. And whoop, there we go. Well, the original problem didn't start with equals 0. I just put it there to illustrate the idea. So we'll take those away. So nonetheless, we have now factored our problem. And we use synthetic just to get us out of the x cubed down to an x squared, something that was more manageable. That being said, could you have used synthetic if you wanted to? Could you have kept going with the process? Absolutely. Some people will write it just like this and keep going. And what we could do is go back to the calculator. We could say, oh, it looks like -1 would be one of our factors. So I'll put a -1 on the outside. So -1 times 1 makes -1. Add those together to make 4. -4, 0. So now you can see I have 2 factors written on the outside. And just remember, whoops, we need to flip the sign. So we'd have an x minus 2 and an x plus 1. And then the new remainder part, which I'll do here in green, the green part would just be x plus 4. And you'll see it's the same thing we got doing it the other way. So it just kind of depends what you find faster. Anyway, I hope this helps you remember how to factor using synthetic division.